About 25% of everything that is recycled is too contaminated to actually be recycled. Recycling contamination occurs when materials are not properly cleaned before they are recycled. For example, excessive grease stains and food residue on the inside of a pizza box. When the amount of contamination in a load of recycling becomes too much, the contamination will spread and cause all of the items in that load to be sent to landfill. Currently, the efforts to remove contamination from recyclables is fully manual. The goal of the contamination detection team is to create a system that can detect contaminants automatically. This will allow facilities to standardize tolerances for contamination in recycling. After countless hours of research, the team discovered that spectrometers could be a viable solution to detecting contamination. A spectrometer uses light waves to determine the material that the light is being shown through by measuring the amount of visible light absorbed by the sample. It then outputs a spectral signature that is unique to that material. By using these signatures, we can differentiate contamination from recyclables with a large enough dataset and a baseline for each of the clean recyclables that we want to examine. A spectrometer is just one aspect of how our system works to detect contamination. To efficiently perform contamination analysis, an onboard camera is used to capture an image of the sample. The image is then used as the input to the blob detection algorithm that attempts to find sections of the sample that are most likely to be contaminated. After pinpointing these areas, the spectrometer performs readings at each location to determine if the blob that was detected is truly contaminated. Once the spectral signature is taken, the system will be able to compare each signature to the dataset and then determine if, for example, that blob was oil, a contaminant, or just water, not a contaminant. The system that was created to house the spectrometer and camera was constructed from 80/20. This serves as the frame and the supports for any vision sensors that would be mounted on the inside of the system. The system is also enclosed to create a consistent testing environment where the samples can be placed and ambient light would not interfere with the readings. The enclosure has its own light source in the form of a ring light to assist the camera with capturing a well-lit image to run the analysis on. Since this is the first iteration of this project, the main goal was creating a proof of concept. A lot of time was spent researching and developing the systems used to detect contamination, so for this iteration, the spectrometer was mounted on a retractable arm near the base plate. Future iterations of this project should incorporate movement so that the spectrometer can automatically move to the potential contaminated areas that the camera detects.